Hello and welcome to Tech Deal's Windows Performance Review on the Intel Core i5-3450, a third generation Ivy Bridge based machine, 3.1 gigahertz base clock speed, turboing to 3.5. Now in a minute I'm going to put it full screen and I'm going to go through my normal Windows Performance Review video. The purpose of this is to simply show you what a 5-year-old computer performs in Windows today in 2017 as opposed to, say, a brand new machine. Now I'm going to run through my standard series of tests. I'm going to run Handbrake, I'm going to do web browsing, play videos, I'm going to do Cinebench, we'll be running WinZip, and a variety of other tests. The purpose of this is simply to demonstrate how useful a 5-year-old machine is today. If you own a computer such as this already and you're thinking, should I upgrade and buy a new i5, say the i5-7400? The answer might surprise you because this does amazingly well. Now, following this video in the coming days, I'm going to be posting some gaming performance reviews with 3 different graphics cards in this Dell Optiplex 310 machine. Furthermore, there will be a link in the video description below to eBay. If you are looking for a deal on a 4-core machine that performs amazingly well in 2017, these can be purchased in the $130 to $180 range on eBay with varying amounts of RAM and storage in them. Inside here is a power supply that is good enough to run up to a GTX 1050 Ti graphics card, or better if you replace the power supply, but as it comes with the power supply, it'll run a 1050 or 1050 Ti, or you can simply use it for web browsing or video editing or rendering even without an add-in graphics card. So without further ado, on to the benchmarks. So now we have the Dell Optiplex 310 loaded up. You can see Windows here running full screen. Now the first thing I've pulled up is CPU-Z, a free program you can download, link in the video description below to show you A, yes, this is in fact the process we're running. B, you can see that we are in fact on the Dell system here. You can see that we have 16 gigabytes of RAM installed, and you can see I have the NVIDIA GeForce GTX 1050. Now I'm going to talk about the 1050 later, and I briefly mentioned it before, but why that's such a good upgrade and such a good deal for this machine. The first thing I'm going to do is click on the bench button and click bench so you can see how well this runs. Now this is a fairly simplistic test, but it's easy for you to run on your computer to see, relatively speaking, how much faster or slower is your computer than this machine. I run this now on all my reviews and Windows performance reviews to give you an idea of how each machine performs relative to each other. Just to show you a few examples here, we'll pull up the latest and greatest from Intel, the i7-7700K Kaby Lake 7th generation chip. Much newer, much faster. Now certainly in multi-threaded here you can see we're almost double the performance, but look at single-threaded, it's not even close to being double. We have a 1 gigahertz clock speed advantage roughly, and hyper-threading, which this i5 doesn't. The hyper-threading makes the difference on the multi-thread test. This here is almost all clock speed. The jump to 2300 is partially the improvements of instruction per clock cycle that happen over the generations, but it's not as much as you'd think. I'm going to come down here now. Let's take a look at a couple generations ago of the i7 CPU. Now it's 200 megahertz slower at 4 gigahertz instead of 4.2, and it's a 4th gen instead of a 7th gen. It drops, but not that much. It's mostly the clock speed making up the difference. The actual instructions per clock cycle difference between a 3rd and a 7th gen, maybe 20%, give or take. The rest is all clock speed improvement. What if we come down here to a 2500K? Now this isn't overclocked, please note, and you'll notice that a 2500K at stock speeds of 3.3 is slower than this Ivy Bridge machine. Part of the reason for that is there was in fact a respectable jump in instructions per clock cycle from 2nd to 3rd gen. There was also a process shrink from 32 nanometers to 22 nanometers. However, a 2500K would really be run overclocked, or it should be, and then that blows this away. But you're getting very similar performance out of the box to a 2500K on this i5-3450. Now this CPU runs at 3.1, or it's rated for 3.1. I'm going to click stress, and then I'm going to come over here to CPU. you can see the turbo in effect. It's currently at 3.3. I know it's 3292, that's just a rounding error, but you see the multiplier here is at 33, so it's basically running at 3.3, not 3.1 gigahertz. That's using all 4 cores. If we stop and hit bench on 1, it may go higher. There we go, 35. So this will turbo up to 3.5 gigahertz, but only on a single core. On all 4 cores, it runs at 3.3. This is a very, very minor difference, but I show it to you simply because I think it's interesting. Now we're going to close this, and I'm going to open up a web browser. I just want to show you that this CPU was launched second quarter of 2012. We're now in the second quarter of 2017, so this CPU is exactly 5 years old. A lot of people probably have a 5-year-old computer and are thinking, oh, well, it's time to replace it. Then they must have made them faster in the past 5 years, right? I'll go out and get a new i5. Well, you might be disappointed if you just go out and buy the current equivalent. The current equivalent is this, the i5-3400, running at 3.0, turboing to 3.5. Sound familiar? This is 3.1 turboing to 3.5. But because of process improvements, it is 12% faster. I know what you're thinking. I'm not going to buy a pre-built. I'm going to custom build, and I'm going to go get myself that 7500. Sure, it's now 24% faster. You're going to replace a perfectly good 5-year-old computer, and you're going to custom build something with an i5-7500 for 24% more speed? I know what you're thinking. You're going to go out and buy a Z270 motherboard. You're going to buy a fancy high-end cooler. You're going to buy the 7600K unlocked processor, and you're going to overclock it. Okay, fair enough. Now you might be 46% faster, but wait a minute, you're going to say, but I can overclock it. Yeah, that is overclocked. Look down here. Now the base clock is 3.5, but the best bench here is at 5.1 gigahertz. That is by far overclocked. This is averaging in overclocked results. So if you have a stock clock i5-3450 in terms of general compute performance, an i5-7600K unlocked overclocked to 4.5, 4.7 gigahertz is only going to be 50% faster. That is a pile of money to spend for a relatively modest improvement in performance. What do I really think you should upgrade this machine with? A Ryzen 5 1600 6-core 12-thread processor is really what I would replace this with. You could, if you wanted to, go to a 7700K. Wait a minute, that doesn't look that much faster, and it does include, if you look down here, 5 gigahertz turbos. That's because it's still a 4-core processor. The big problem with the latest and greatest i7s, unless you go to Broadwell E, is they're still 4-core processors. Hyper-threading is nice. It makes games smoother. It makes multitasking smoother. It doesn't make your computer that much faster, except in very, very limited circumstances. So coming back to the i5-7400, it's an upgrade, but not really. If you still have an i5-3450 and it's working for you, keep it. There's really no need to upgrade right now unless you need more cores, more threads, and more capability. And right now, I believe launching April 11th, that's going to be the Ryzen 5 1600 is the sweet spot. $220 plus $100 for a motherboard puts you at $320, and that includes a cooler, and that is 6 cores, 12 threads versus these 4 cores, 4 threads. That's the deal here. But do not misunderstand me. This i5-3450, amazingly capable computer. I mentioned before graphics cards. I'm going to show you this briefly because we're going to go take a look at desktops here in a second on eBay. If you want to buy one of these, that graphics card is worth taking a look at because the small form factor, the thin pre-builts, are less expensive than the full towers. Now, you can put any 1050 or 1050 Ti into the full mini tower cases, which is what I have, which is what I showed you earlier. But if you have a thin tower, they do make low-profile GTX 1050s that you can install in those. When I show you game performance benchmarks on this computer, it's going to be using a GTX 1050. It's not actually going to be that one because I have a full mini tower, and thus I have the EVGA Superclocked. And in fact, I'll show you that. Here we are at the Evga Gtx 1050 Superclocked. Now, after mail-in rebate, this is $10 less than the MSI card I just showed you. This is actually the card that I used for the gaming benchmarks in this machine. So buy one of these computers for $100 to $150, drop one of these two cards in for $100, $110, and you've got yourself a very capable basic gaming machine. Can you put a better graphics card in? Yes, a GTX 1060 will work, but you generally will have to replace the power supply to do it, which is an option, but just adds to the cost and complexity. Now here we are on eBay. Now I have done videos in the past where I talk about this, so I won't go into it in great detail, but in short, if you search around and keep your eyes open, you can find a heck of a deal here. On the day I'm filming this, the least expensive machine was $138. Everything just got sold, what can I say? Now, just to give you an idea of what these machines are actually selling for, here are the sold listings on eBay. Here is the exact machine that I have that I showed you before, $139. Now, this has 4 gigs of RAM, and I have 16 in it. 16 is not necessary. It's nice. You could certainly go with 8. You could put another 4 gigabytes of RAM in and go from 4 to 8, and that's not terribly expensive. It also came with a 1 terabyte hard drive, which for many people is enough. Notice it also comes with Windows 10 Pro. That's nice. So take this, drop the graphics card in, and basically for $250, less than $300 upgraded to 8 gigs of RAM, and you have got yourself a nice, inexpensive budget gaming machine for less than the cost of most brand new game consoles. Now, if we scroll down here, take a look at these small form factors. See these slim machines here? These won't take a standard card. That's why I showed you the MSI low profile card. That's what you'll need for these slim, small form factor machines, whereas this mini tower will basically take any standard graphics card, assuming you put in a decent power supply or just use the EVGA. It works just fine. All right, enough of all that. So you get the general idea. You see where it's placed in the market. Let's run some benchmarks. This is Cinebench R15, another free benchmark you can download. Link in the video description below. Cinebench simulates 3D rendering. Well, it doesn't simulate it, it does it, but it simulates like if you were going to run a program such as Blender or one of the commercial products that allows you to do this sort of work. Would this benefit from a more modern processor? Yes. Would it be faster on an 8-thread or 12-thread processor? Yes. The question I would ask you is, are you playing around with 3D animation for fun, or are you doing it professionally? If you're doing it professionally and you're getting paid, there's no excuse to be on a machine such as this. You need to go and get yourself a better computer. In fact, frankly, if this is the kind of work you're doing, Ryzen was made for this, the AMD Ryzen chip. And an R7 1700 would be the chip that I would buy for this type of work. But if you're a casual 3D, if you just do this for fun or for side projects, shoot, why not? Less than $150 buys you a machine that runs this just fine. Please note, you do not have to put a GTX 1050 in here to run 3D rendering or video encoding. That's strictly for gaming. You absolutely can just use the integrated graphics if all you're going to be doing is Windows type work and 3D animation type work. You don't have to add a graphics card for that. And we're almost done here. You can see 4 boxes at a time going. That represents the 4 threads. An 8-thread processor would do, how did we get? 463. It's a modest score. Certainly it does not stand up to more modern machines, but now you have at least an idea of what this will do if you're interested in 3D rendering on an extreme budget. The next test I want to show you is a program called 7-Zip. 7-Zip is a compressor decompressor. If you're familiar with WinZip or WinRAR or any of the other compressors, it's a program that allows you to take a group of files or even just a single file, compress them down to a smaller size for either storage on external media such as a DVD or CD, a USB flash drive, or these days in the digital world, emailing or uploading to the cloud. Now, this is a built-in benchmark, and the nice thing about 7-Zip is it includes one. I could absolutely take a fixed group of files and folders and just compress them and then decompress them and time it. The problem with doing so is that then takes your storage medium into account. How fast is the hard drive or SSD I'm using? And it will affect the results. This is just pure computational ability. How fast can the processor compress and decompress, because your storage is going to be different than mine or anyone else's. Look at the resulting numbers here. These are the numbers on the right-hand side that you want to look at. And you want to look at the bottom numbers. The top ones are in real time. It runs this benchmark over and over and over, and it's taking an average of the actual results. So we're looking at 14,764 for compression and 13,452 for decompression. Free program linked in the video description below. Go download it and try it on your old machine. These numbers are relative. If you get twice this, it's twice as fast. If you get half of that, it's half as fast. It's pretty straightforward and simple. An easy way to tell how fast your processor is compared to, say, this one or another one of the ones I've tested. The next test I'm going to run is the Heaven Benchmark 4.0. I'm showing you this screen because I want to show you the preset I'm selecting. We're coming down to Extreme, and I'm going to hit Run. The reason for that is to make it the same every time I do this. And here we are. Now, normally it just sits here and runs around in circles. I'll turn the sound off for the moment. This is just the demo mode. It's just going to run around and around showing you. This is heavily graphics card dependent. Now I have the Evga 1050 Superclocked installed right now. And if you go to eBay and you buy one of these computers, or you have one and you want to put a good graphics card in, and you put that graphics card in the Evga 1050, this is the performance you'll get. If you go with a different graphics card, you'll get different performance. Now I'm going to click the benchmark button here, and it's going to start benchmarking. This runs through 26 different scenes. It takes some time to run, but it's important to watch the smoothness and the actual progress of the benchmark and not just the result. I cannot stand just looking at slides or minimum, maximum, and average frame rates, because what it doesn't tell you is how smoothly it runs. How do the transitions go? Is it, what's the quality of the image? These things aren't just in a number or a table. So I like to actually put the entire run in here. It's why I do live game benchmarks where I actually show you the gameplay. I could absolutely do a video, test 10 games, put up 10 slides, talk about them for 5 minutes and say that's a video. But it's very deceptive sometimes, because how smooth or controllable gameplay is or a video is may not be reflected in just a few numbers on a slide. All right, I'll be quiet now, put some music on, and let you enjoy this, and we'll be back when this is run through all 26 scenes. And here as we come up to the last scene, you will notice that our frame rate absolutely dipped at several points in there to a fairly low level. We did average 41.7 average frames per second with a score of just over 1,000. The minimum was 7.9 and the max was 92. Now I'm including the Heaven Benchmark 4.0 in all of my new Windows performance reviews. I've tested Ryzen on it, I've tested the i7 on it, I've tested newer machines on it. Now this gives you something to compare if you want to know how well this runs versus some of those, but please note the graphics card makes a difference. We have a 1050 in here, so it's not going to perform as well as a newer machine that has a 1060 or a 1070 in it. That being said, this gives you a rough idea of what to expect if you take modern AAA gaming titles, put them at max ultra detail, and you want to go play them. Is a 1050 going to do it at 60 frames per second? No, it really isn't. However, if you lower the details down to medium, it will play most current games at 60 plus frames per second without an issue. A 1050 is not designed to be an ultra gaming card. It's more of a medium to high detail gaming card. It does that just fine. All right, let's close this. The next test I want to show you is also something you can run on your computer. This is user benchmark. Now, I showed you this earlier. I showed you the website. I'll go ahead and click run. I showed you the website comparing the i5-7400 to this i5-3450. This is where those results come from. Every time this gets run on one of these different machines, the results get uploaded. They're anonymous. They don't identify you, but they get uploaded, and so there's thousands and thousands and thousands of results in there, averaging across all the variables. I'm sure they toss out the top ones and the bottom ones, and they're looking for what's the middle 80% of the numbers. That being said, this allows you to get a specific score for your specific machine rather than using their numbers. So we'll see how well this compares to the standard i5-3450. I would expect it to be right in line. So in terms of median result, it should be right in the middle of all the other tests. Now this does test the drives and graphics as well, which are more specific dependent. I'm not even going to look at the storage options because I didn't even talk about the SSD and the hard drives that I have in here because you are going to have something different. What really matters is the CPU more than anything else. And here the results are complete. Now once this is complete, it'll open in your default web browser and then you can close the program. It is worth noting that you have a URL you can share. By all means, share your results if you would like in the comments section below. All you have to do is copy here. It's userbenchmark.com/userrun/ whatever your number was. Mine is 3129063 if you're interested in typing it in and taking a closer look. Short version, for gaming, we are a 36% jet ski. What does that mean? Well, it's good, but not great. If you take a look at the performance classifications, the best possible result is UFO, and the worst possible result is tree trunk. By the way, if you are a tree trunk, or you have one, post that in the description, in the comment section below, and we can all chuckle and say, hey, you need to get a newer machine. For a general desktop PC, we're a gunboat, we're at 55%. Yes, there are faster machines, but for general desktop use, it's pretty good. Workstation, 3D animation, video rendering, multi-users, virtual machines, it's okay. It's not great. The reason the gaming result is so low is the graphics card, so don't get too excited. Their standard here, GTX 1070, is 100%, so we are 36% of the speed of a standard GTX 1070. If we had a 1060 in here, then this would be closer to 60 or 70%. Rather than 36. It makes a big difference what graphics card you have. Overall, this PC is performing above expectations, 66th percentile. That means out of 100 PCs with the exact same components, 34 perform better. Hey, we're doing pretty well. If we scroll down here, take a look at the CPU. Now these are our individual scores, single core, quad core, and then multi-core. The multi-core number is low only because we only have 4 cores. The quad core is fine. Multi-core, if we had, say, a Ryzen 5 1600 with 6 cores, 12 threads, that would be like 1,000,000 times better. And if you're doing that kind of work, that's where that comes in. But if you're only using up to 4 cores, then this runs really well. Here's our graphics result. You can see here that we are okay. We're right in the middle, 43rd percentile. It's fine. It is reasonable for basic work, but do keep in mind that it will not remotely approach ultra level gaming with a 1060 or 1070 because it's a 1050. Now, I said we're not looking at the drives. I have a very cheap Silicon Power SSD in here, and I don't even know that it is in fact connected to a SATA 3.0. It might be a SATA 2. Ignore these results because you're not going to have one of those. If we come down and look at the RAM, you'll see we have 16 gigabytes of DDR3 clocked at 1600 megahertz, which is, actually it says performing way above expectations. Yay, RAM. The whole point of running this is simply to determine how well does your specific machine run compared to the standard of this hardware. This is a very good reality check. Is my computer running the way it should? Is it running how this specific hardware should be running? Now, you may get higher or lower numbers, but if you are in the 40th to 66th percentile somewhere in there, then that means your computer is running right. You're getting the performance that you should be expecting. The next test I'm going to show you is Handbrake, a free transcoding and encoding program that you can download yourself. Again, link in the video description below, as well as a link to the test render file that I'm providing to you so you can run this exact same test using the exact same settings, using the same source file on your own machine if you would like to compare the results. Now, this is a game performance video I've previously recorded. It is 5 minutes and 1 second long. Rise of the Tomb Raider. It's a 1080p, 60 frame per second, H.264 file. We are going to convert it to H.265 using the built-in Roku 2160p, 60 frame per second 4K surround. Now, it is not going to upconvert it. We're leaving the resolution the same, but it does force the conversion to H.265. Now, this is fairly slow. Don't worry, I am not going to show you the whole thing. I'll click Start Encode, then I'm going to trim this and show you the results. This will take a while. It will take a while because we have an older 4-core processor that is missing some of the new instruction sets that are included with newer versions of the processors. This is one of those situations where you will get a greater performance jump on a newer CPU due to those specialized instructions. Some of the older 2nd and 3rd gen chips don't have the latest and greatest AVX or AVX2 or SSE5 instructions, which some of the newer chips have, that greatly speed up the performance of video transcoding. However, if you're going to do this casually, run it overnight. Even if it takes 3 hours, if you're just going to run it overnight and not sit at the computer, what possible difference does it make? There's also an argument to be said that if you do a lot of video encoding and you don't want your computer to be tied up, having an extra computer to do your encoding on makes a lot of sense. I don't use my computer while it's trying to encode video. I have other machines, and so I can edit on one computer, and then I can have another computer encoding or play a game or browse the web or do whatever it is I'm doing. In fact, I can have 2 or 3 computers encoding if I had several files at once. Even if you have a newer computer, if you're constantly finding that it's busy encoding a video, if you do a lot of this stuff, for $130 to $140, you could buy one of these. Don't bother putting in a graphics card, just use it as it comes out of the box and just make it a dedicated encoding box. And even if it takes 5 hours to encode a 1-hour video or even a 30-minute video, if you're not time sensitive on when the video gets finished, put it in the corner, put it on a cheap small monitor, set it to encode, and go do something else with your main machine. If you look down at the time, actually this isn't too bad. It says 25 minutes remaining. Now that's going to increase. In this video, there's black scenes and white scenes where it fades to black. This is the first mission of Rise of the Tomb Raider, and so there's parts of this that are very easy to encode that go pretty quick. Look at the time remaining. It's going up, not down. We're at 25 minutes 34, 25 minutes 39. That's because the first, 30 seconds of this is all black screen until it fades into the mission. Download the video file using the link in the video description below if you would like to try rendering this on your own machine. Just make sure to use the Roku 2160p 60 frame per second preset to get the same results, or at least to get the same settings, because if you use something different, then it's not comparable. Let's trim this now. We'll be back when it's almost finished. And here we are, complete at 52 minutes. That actually ended up taking longer than I expected. It slowed down later in the video file, probably due to complexity. This is why it's so important to be using the same file, not just the same length, because the complexity of the scenes and what's actually in there makes a big difference to how long it takes to render each individual file. Again, link in the video description below to the source file you can download yourself, as well, of course, to Handbrake. Finally, that brings us to basic web browsing, watching videos, and multitasking performance. We are here in Microsoft Edge web browser looking at my channel, youtube.com/c/techdeals. First things first, I'm going to click on the videos tab, and I'm going to open up 1, 2, 3, 4, 5, 6. Now, I am opening up 6 videos. I'll go ahead and close that one. And I'm going to make each of them into theater mode. Why? To force them into HD and make it nicer full screen for you. It's worth noting that playing back videos is generally not very difficult, especially with the graphics card we have that has hardware decode in it. Hey, there's the new Ryzen 5 video. These are all going to play back just fine, but it's a good demonstration of the fact that a reasonably modern computer with a reasonably modern graphics card has no issues playing back video. Now you might say, wait a minute, do we really need a graphics card for this? Well, not particularly. You could use integrated graphics and play it back. However, as you go back in generations, there comes a point, off the top of my head, I can't tell you when it is, where the integrated graphics on processors did not have dedicated hardware playback circuitry. I actually believe the i5-3450 does and will play back 1080p video on hardware, which means playing back 6 videos, look at our CPU usage, we're at 11%. This is absolutely nothing. Here, we have a 720p at 60 frame per second video. Over here, another one, 720p, 60 frame per second. Hey, look at that mayhem and carnage await in Grand Theft Auto 5. That is entirely too much fun. All right, we can't watch that, or I will just look at it. World of Warships, another fun game. So basically, all these videos are playing in HD at 60 frames per second. CPU usage? Oh, there's some to be sure. We're hardly even using one core, and that's because all the grunt work of decoding 6 videos at the same time is happening on the integrated dedicated circuitry for decoding videos. It's not using normal compute power. So your computer is completely available for anything else you want to do with it, such as coming over here to Amazon. Hey, look, Dress Shop Girl is there. In fact, if I hit refresh, we can watch her dance around. Or as my wife calls her, Leg Shop Girl, because that's what I think she's selling. In any case, let's take a look at the i5-3450 CPU. Now, you can buy a new one here. Don't buy this. That's absurd. Why they think they'll ever sell one at that price is beyond me. You can buy the whole computer for less. But, you know, that happens occasionally. Much more interesting is going to be something like these listings. Now, here you're going to find, there we go, certified refurbished, $189. Now, that's more expensive than eBay. Generally, the sellers on Amazon do charge a little bit more than on eBay for used and refurbished machines such as this. There are fewer people who sell such computers. Amazon is more focused on brand new products and less so on used, refurbished products, but you certainly can buy them here if you don't want to mess around with eBay. There's the exact machine I'm using right now. 4 gigs of RAM, 500 gig hard drive, $190. But that's more expensive than they are on eBay. I never want to tell you don't buy somewhere, but what I will tell you is eBay is where I buy all of these machines. You can get them here if you want, but frankly, the prices on used Dell machines or HP or Acer are cheaper on eBay. I previously mentioned the i5-7400. If you want to buy a new machine, if you want a brand new computer that has 8 gigs of RAM already, 2 terabyte hard drive, you don't want to mess around with used computers, that's a nice machine right there. And that comes with a 300 watt power supply that will let you use a GTX 1060 without changing the power supply. I know because I have it, works absolutely wonderfully. But it's $450. Add a graphics card to it and you're well over $500. But it is new. But remember our tests? It's not that much faster than an i5-3450 or frankly even an i5-2400. So do you want that extra bit of performance or do you want to save a lot of money? The choice is yours. I am now going to open up a lot of tabs here to show you how easily this handles a lot of stuff on the screen at one time. So here's the main computer page. In fact, there's a little Ryzen icon right there I'll click on. There are the existing Ryzen 7 CPUs launched. Here's some laptops. We'll click traditional laptops and I'll scroll this down. Very nice. Desktops, we'll click towers and we'll scroll that down. There's that Acer Aspire I just showed you. Here is, if you don't want to mess with installing graphics cards, that's the one to buy. $720, covered it many times. i5-7400 RX 480. That machine is a beast. Plays everything at high or ultra at 1080p perfectly with no compromises. I love that machine. It is a very, very good computer. All right, moving on. Monitors. You want an unbelievable deal on a monitor? Where the heck is it? That's not bad. If you want a 27-inch, this is the deal. 32 inches may seem large, and it is large. 32 inches, $199. I own two of them. I've covered it twice. That is a really beautiful screen. IPS in-plane switching, great color. DisplayPort, HDMI, and VGA inputs, USB hub. For $200 for a 32-inch IPS monitor, deal. Computer accessories, keyboards, we can click all this stuff. Here's the point I want to show you. This multitasks very well. This scrolls very smoothly. We're still playing videos. Hey, we're into another game over there. Oh my goodness, that's going to hurt. Can we switch back over? I'll Alt-Tab. Yep, there we are. We can scroll. There's no lag whatsoever. The point is it's very responsive. The point is you can multitask on this just as well as you can on a brand new i5. Computers have been fast enough to run Windows for some time now. So if you're thinking your 5-year-old computer is not good enough, now if it's an i5, it's plenty. Now if you have something else, if you have a different machine, I'm not talking about those. But if you've got a i5 from even 6 years ago, an i5-2400 would be fine. This is an i5-3450, which is largely the same chip, one generation newer and 22 nanometer production process. No complaints. I mean, I could load it up. The reality is I could open 20 or 30 tabs. I could open 3 or 4 different programs. It would handle all of it just fine. Part of that is I have plenty of RAM. There's no challenge for the amount of RAM that we have installed. Hey, we changed to a black car. That was a red car before, and that just goes to show you it is in fact playing these videos in the background. I mean, I could open up 12, but really, who watches 12 videos? I think that makes the point. So that has been the Windows performance review on the Dell Optiplex 310 desktop computer. Very nice performance. This is an amazing machine for 5 years old. Those of you who were around the PC business back in the 90s and the early 2000s may remember how quickly technology evolved. If you took a computer from 1995 and then later in 2000 and then again in 2005, you could not remotely expect them to be terribly useful 5 years later running modern current programs. Here we have a computer that dates from the beginning of 2012. Here we are in 2017. This genuinely is 5 years old. Now, it does have some extra RAM in it, and it has a solid-state drive which improves its performance. However, it is amazing how completely useful and capable a 5-year-old machine really is. Now, as I said before, there'll be links in the video description below to eBay, taking you to a pre-searched, pre-sorted list for all the i5-3450s on there. If you are interested in checking one of these out, there's a variety of options for upgrading it and improving it. I am going to show you now the graphics card that was installed in this during the previous video. And now you can see inside the Dell Optiplex 310. Now when it comes to the i5-3450 CPU, you don't have to buy this specific computer. It's simply an example or representation of what you can get for the money. You can see right here, I've got the Evga GeForce GTX 1050 non-TI card. This is the $99 card. It is the Superclocked edition, runs very well out of the box. It installs, there's no cable, there's no connector that you need to plug in. You don't have to change the power supply, it works great. Now, if you want more graphics performance, this computer will absolutely take a GTX 1060, which is 75% faster than this, but you really should replace this power supply if you're going to do it. Most of these machines do not come with enough power supply to run that. So Another $30 to $35 for a new power supply. All the standard cables in the Dell machines are the same cables you'll find on a regular ATX power supply. But if you're really considering doing that, you might want to buy a newer machine simply because you then don't have to mess with it. A lot of value for the money. So this has been the Windows Performance Review on the i5-3450. Like this video if you like it, share it with your friends if you loved it. Remember to subscribe to my channel with that big huge red button directly below. Questions and comments in the comment section. As always, check out the links in the video description below. Links to eBay, as I mentioned before, and my link to Patreon. I'm going full-time April 1st. If you'd like to support me and you like my videos, I would greatly appreciate it. Even $1 is helpful. Thank you so much for watching my videos. I will see you next time.